Integration by substitution, example 1D, all right, integration. All right, one of the things you'll notice is, again, from here to here, from the question to the board, I perform the first step of changing that radical to a fractional exponent. Cube root would be 1/3 power, and I brought it upstairs. So negative 1/3. This is a product, but here's the deal, and you do as much algebra as you can. The best case scenario is to have terms and powers. Here's the problem though. We can't distribute this into the parentheses because the exponent takes precedence over this, over the multiplication. And we can't drop the power in there because of the subtraction. So I would just describe this currently as being algebraically landlocked. And it's currently a product, and there's no product rule for integration. Okay, so, and look, you have the advantage of knowing that this is the substitution assignment. So, substitution. As was suggested, if we have a quantity being raised to a power, then that would be the logical thing to set equal to u. And so again, instead of having quantity to a power, our new integral over here is going to be u to the negative 1/3 power. Isn't it easier, better, to have a single variable to a power instead of an expression to a power? Especially when that expression contains addition or subtraction. All right, so then off of that, I always tell people build the dx from this and see what happens. So we differentiate both sides with respect to x, and this would be 12x, right, derivative, 12x, dx. Clear the fraction. I hope you see the pattern. Watch these examples in order. They build off each other. All right? So we end up with du equals 12x dx. Now here's the deal. We're always going to get the dx. That was the whole motivation behind differentiating both sides with respect to x, was to get a dx into the discussion. But frequently, sometimes, you'll get another expression in your lap. And I'd like to point out that the 12x there is kind of like that, instead of, but we prefer it be 9x instead of 12x. But the thing is, we don't really have to construct this because it kind of fell in our lap. But here's the deal, we don't want that to be a 12, we want it to be a 9. Big deal. Here's what I would suggest. How do you change a 12x into a 9x? Sounds like a joke, huh? How do you change a 12x into a 9x? Here's my logic. Let's cancel out the 12. So let's introduce a fraction with 12 on the bottom to cancel out that 12 and replace it with a 9. What's 9 12s times 12x? 9x. Ding, ding, ding. Cancel the existing number and replace it with the one you want. Now, I get it. The fraction 9 12ths reduces to 3/4. We're multiplying both sides by the same thing. I've learned, though, that if I put 9 12ths here, it's more obvious to people that the right-hand side becomes, cancel the 12s, 9x dx. And you go, cool! That matches the original integral. And then 9 12ths is equivalent to 3/4. So this side is 3/4 du. So it turns out that the 9x dx in the original question is equivalent to 3/4 du. I always put the multiplier, the numerical multiplier, in front of the integral just to avoid confusion there, and the du. So the 9x dx got replaced with 3/4 du, and everything in the original integral got replaced. Yes! And that new integral is easier than the original. That's the whole point in doing substitution. So all we got to do is the power rule on this. N plus 1, let's see, negative 1/3 plus 1 would be positive 2/3, and then over 2/3, which invert multiply 3/2. I hope you're getting used to doing that. And then plus the constant, indefinite integral. We're back to doing those again for a while here. And then let's multiply this out. 9/8 u to the 2/3 plus c, and we're almost done. But again, trying to think of a name here for myself. Mr. Soldering Gun, I have to count it wrong if you stop here. Because remember, you're just replacing that variable x with u to make the integration easier, but that's not your answer. The answer is to substitute back. Remember to substitute back, that's easy to forget. And so we'd have 9/8, and then u is that expression, 2/3 power plus c, boom. I'm supposed to count it wrong if you don't substitute back. The question was to integrate a function involving x. The answer should be a function involving x. If we forget to substitute back, I gotta count it wrong. I have to. Please remember to do that. I will probably be kind if you forget to put the plus c, but I'm supposed to count it wrong if you forget to do that as well. So just little things like that. There it is. So, take a look at that. As always, you can hit pause, you can do whatever you want with it, but I'm hopeful that these would be helpful to you when the time comes for you guys to enjoy assignment 27 on your own, and take a picture of it and send it to me. All right? Rock on!